Welcome back to this tutorial series on Fix API for algorithmic traders, and today we'll be talking about how to establish a fix session between a trader and broker employing Fix. In terms of agenda, we'll go through credentials and TCP/IP connectivity, these being the prerequisites for establishing the Fix connection. We'll go through an overview of a typical Fix authentication sequence. This will, however, focus purely on pricing connections today. If you're unfamiliar with pricing connections, this is something that was touched upon in the previous tutorial on the anatomy of the Fix protocol. I encourage you to watch that prior to watching this video tutorial, as the concepts we discussed therein will prove immensely useful in order to understand how things progress in this tutorial today. We'll go on from there to break the authentication sequence down into messages in terms of components required, the flow required, how they're constructed, and some specifics, some calculations, in fact, that will explain how those are done inside the message once it's constructed for validation purposes at both ends, the traders and the brokers. And we'll conclude with talking about future tutorials and how we'll take this conversation forwards from establishing a Fix connection to conducting business. Before we move on, though, it's important to address a myth that circulates among a reasonable proportion of algorithmic traders who've considered Fix or are considering Fix as a protocol to use as a means to market at the moment, and that is that the Fix protocol is somehow complicated. And that's simply not true. Perhaps the reasoning behind that is to do with the fact that the Fix protocol is one of the few that is not as documented as algorithmic traders would prefer it to be. There is perhaps a book or two that employs, that discusses Fix implementation, particularly in a single asset class or two. But apart from that, there's just the Fix protocol specification depending on the version that's available online through the Fix trading community website or from your broker who, if they provide you Fix access, will of course provide you the Fix specification to go with it, as we do at Darwinex. So the reality there is that the Fix protocol isn't complicated. It is simply a system of rules that are followed by the two parties employing Fix. And they use that to do two things. They use it to recognize each other, firstly. And once they've recognized each other, they conduct business thereafter. And that's simply it. There's no complication in the protocol per se, because the protocol is a means of defining these relationships. So rather than go straight into the messaging flow and structure and component tags thereof, etc., perhaps it would help us to go through this process, the system of rules, and talk about the session that we're going to describe in more granular detail later, a bit more visually and relate it to an example in our own lives. For instance, what do we do when someone knocks on our door? Odds are that if we don't know them, we'd like to identify them. So let's go through this in terms of the Fix protocol and see how we can mirror the same example using the Fix protocol. And to do that, let's head straight to the drawing board. Assuming that this individual at your doorstep is the trader and you are the broker, and you're both using the Fix protocol to communicate with each other, then the trader needs to offer up a few pieces of information that are essential for you to consider establishing a connection at all. And these are the following four tags. You have SenderCompID, the TargetCompID. The trader also needs a unique username and a corresponding password. Using the Fix protocol, this trader will then package this information into a Logon request, a special message of message type A. If you remember the message type tag 35 from our previous video on the anatomy of the Fix protocol, the trader here is going to compose this message and then send it across to the broker at this point in this Fix session. The broker would then go ahead and validate this information and have one of two responses to offer back in return. If the credentials are correct and everything checks out, then the broker will send its own logon message back to the trader that, yes, credentials check out, logon request with message type A sent back to you. However, if the credentials are incorrect, or if there's anything else that is wrong with the way the message has been constructed, the broker will issue a logout message back to the trader and terminate the connection. That message will have value 5, message type equals 5. In Fix terminology, the trader is the initiator and the broker is the acceptor. And to engineer a logon request in the first place, not only does the message type, of course, need to be A, 35 equals A, but there are a few other flags that need to be set in a pricing connection that we're talking about today that are necessary for the connection to be configured correctly. And in this case, the reset sequence number flag, which is tag 141 in the FIX version 4.4 protocol, that needs to be set to Y. This indicates to both parties, indicates from the initiator to the acceptor that it is requesting that both parties reset their message sequence numbers. And that makes sense in a pricing connection. By resetting the sequence numbers, there's no possibility of entertaining any past messages. The sequence is started afresh. In a logon message, whenever you start the session, the message sequence number that needs to be specified in that message, if you remember from the previous tutorial, Anatomy of the FIX protocol, the MSG sec num flag, which is flag 34, needs to be set to 1 when initiating a logon request to start a session. A FIX logon message also requires a few additional parameters that need to be sent across in the first instance, and these include the encrypt method, which is tag 98. Setting this to 0 indicates that no encryption is being used. We also need heartbeat interval, which is tag 108. We'll go through heartbeats in future tutorials, but for now, a heartbeat is essentially an indication from one party to the other, sent after a predefined number of seconds, whereby the parties can inform each other that yes, we are both alive on the connection and that we're processing messages efficiently and that we're here if you need to send anything more. That's all there is to it. So the heartbeat interval message tag 108, in this case, let's, for example, set it to 20 seconds. I'd like to send a heartbeat every 20 seconds. It's entirely up to you and completely dependent on your implementation. And the rest of the message needs to contain the header fields as we discussed in the previous tutorial video, the standard header fields, which include the begin string, body length, and sending time. And of course, these are all in addition to the credential values that we talked about earlier, which are the SenderCompID, TargetCompID, username, and password. Now let's see what this message looks like when fully constructed into a FIX message with all its tag value pairs sequenced in the order that they're expected by the acceptor entity. So as you can see, we start off with the standard header. We define the begin string as fix.4.4, the body length of 70. These are example values here as I've just written them on this slide. They haven't been calculated as they should be in an actual FIX message. So therefore, these are purely for demonstration purposes. This value may change, and I'll explain the body length and checksum values shortly on how they're calculated, what the procedure is to calculate those, as it is very important that those values are correctly sent across to the FIX engine at the receiving end, because if they are not, then that will result in a rejection of the message. So we start off with begin string is fix 4.4, body length of 70 in this case, 35 equals A is the logon message, 34 equals 1 is the first message sequence number, 49 is your SenderCompID, which we've just used an example of ABCD, 56 equals TargetCompID, which is EFGH, 52 is the sending time, is the moment at which we've sent in UTC time zone, the time at which we're sending this message across. The encrypt method 98 is 0, meaning no encryption used. Heartbeat interval of 108 set at 20 seconds, for example. Reset sequence number flag 141 set to Y, and username tag 553 set to an example username. Tag 554 is the password tag and with another example value. And finally, the checksum is set to 111 in this case, purely for example purposes, just to demonstrate what the entire message looks like. But there is a particular procedure to calculating the checksum, as I'll explain shortly, as well as sending across the correct body length, as I'll also explain shortly. And while we're talking about all of this, it's important to bear in mind that while this all may look fairly cumbersome on the surface of things, with lots of tag value pairs to specify, separation control characters to be put in place, all of this is easily automated using scripts that we'll write in future tutorials, also via using the QuickFIX fix engine that we'll be demonstrating in future tutorials. And you needn't worry yourself with the structure of this in terms of having to construct this manually each time. That is not at all the case, and it'll be fairly easy to automate this generation in future tutorials, as we'll see. For now, let's talk about how the body length and checksum values are calculated before they're sent across to the acceptor. The last field in any fixed message contains the checksum value for the entire message. And this is calculated in this case, for example, our example here contains pipe characters separating each field tag value pair. So in our case, what we're going to do is simply replace all these pipe characters with the appropriate control character, the start of header character /x01, as we discussed in the previous tutorial on the anatomy of the fixed protocol. And once that's done, we now have a string that we can encode in UTF-8 and convert to bytes. Once that string, everything before the checksum field has been encoded in UTF-8 and converted to bytes, we then simply need to take the sum of all those values and divide that number by 256, the modulo operation, divided by 256, and whatever number we get equals the checksum. Bear in mind that if that number, for instance, is 2 digits, not 3, the FIX protocol specification version 4.4 dictates that the checksum has to be at least exactly 3 characters. Therefore, for instance, if the result of this operation resulted in, for example, 18, then you would set your checksum value to 10 equals 018. You essentially pad the remaining digit that needs to be in place with a 0, and that constitutes the checksum value. The body length field forms part of the standard header and is much simpler to process than the checksum, of course. In the fixed message, the number of characters that are in the fixed message, excluding the begin string tag value pair, the body length tag value pair, the control character between them, the checksum tag value pair. Once you exclude these things, whatever characters you have left, the number of characters there are equals the body length. It's a very simple process. Now, you may be wondering after listening to all of this that there seems to be a fair bit to do when processing a single message in Fix. And the answer to that question is yes, there is. But the decision to do it all yourself is the only thing that will introduce the additional time into doing this the first time. It is highly encouraged that you write reusable code, and that's something we will be going through in future tutorials, how to write reusable code so you don't have to go about calculating checksums each time you write a new piece of code, etc., etc. And then there's also the question of, well, for tasks such as this, calculating checksums, figuring out body lengths, etc., do we really need to write the application code necessary for achieving all of these tasks? And the answer is no, because there are open source fix engines available, such as QuickFIX, that we'll be demonstrating in future tutorials and writing code using, in fact. These are calculations that need to be done for every single message. Therefore, the fix engines ship with code that does this automatically as part of the application flow, leaving you to focus more on the logic of your application as opposed to doing these lower level calculations and constructions with fixed messaging. So bear that in mind. The objective here was to demonstrate and make you aware of what goes into a fixed message, how the different components are put together, constructed, which ones are required, when and how, what the responses are to a certain construction of a message from an initiator, sent from an initiator to an acceptor, and vice versa. And the idea here was to demonstrate how all of this works and how all of it is put together. Future tutorials will, of course, focus on how to do this efficiently using open source fix engines. In our case, we'll be using the QuickFIX engine, and describing in detail how to work on application flow so that you end up making a fix-enabled trading strategy as opposed to spending too much time on doing the lower level bits that need doing as part of everything. As always, if you enjoyed this presentation, please do consider sharing it with your social networks, colleagues, co-workers, and friends. And do subscribe to the Darwinex YouTube channel so you remain up to date with all future videos that will be released in this series and other topics discussed on Darwinex. Thank you very much for your attention. See you next time.